For this video, we're going to talk about solving one-step equations. As it turns out, one-step equations and inequalities, one-step inequalities are solved the same way. There is a PDF on here, so if you want to go ahead and print it out, go ahead and do that. First thing we're going to talk about are inverse operations. What are they? Two operations that undo each other. They are opposites, like addition or subtraction, multiply and divide, or squaring something and then taking the square root. To undo a square, we don't divide, we take the square root. Equivalent equations, two equations that are equal after you perform the same inverse operation on both sides of the equation. We'll talk about that when we see that again. Reciprocals, again, we've seen this before. Two non-zero numbers whose product, that means when you times them together, is equal to positive 1. And words that indicate. This is a key word. If you go to the search button on MrAlgebra.com, you can type in word. Actually, I think it's supposed to be words. It should be words. Words that indicate, or you can just type in words. Add, subtract, multiply, and divide. So when we build our equations, we know what words mean to add, subtract, multiply, or divide. And this will pull up a list of 4 documents, 4 PDFs that have a whole bunch of words that mean add and words that mean subtract, multiply, divide. So go ahead and do that if you like to. First thing is we're going to solve by using subtraction. This is an addition problem. We're going to solve for x. We're going to isolate x. And we're going to use the inverse operation of addition, which is subtraction. So we're going to minus 7 to undo the plus 7 from this side. But to keep things in balance, we have to minus 7 from the other side. That's actually called the addition property of equality. We can say that we're adding a negative 7 instead of minusing 7. That's why we call it addition. So this becomes x plus 0 is equal to 4 minus 7 is negative 3. And x plus 0 is just x. And x would equal negative 3. And to be certain that you did it right, what you should do is take this negative 3, substitute it back in place of x. Negative 3 plus 7 is equal to 4. And we get 4 is equal to 4. And it does check out. Okay, so subtraction is the inverse operation of addition. So if you see a plus, you're going to undo that with minus. Same thing for addition. To undo a subtraction problem, we're going to use addition, which is the inverse operation of subtraction. So to undo, we're going to get x by itself. So solving means to isolate the variable. We're going to get rid of the minus 12. So to undo that, we're going to add 12 to both sides. This is our addition property of equality again. And this will give us x plus 0, or minus 0 if you want to call it that, is equal to 3 plus 12, which is 15. X plus 0 is just x. And then, of course, we're supposed to take this 15, substitute it back in place here. So that gives us 15 minus 12 equals 3. We see that 3 equals 3, and that checks out as well. So we do know that x equals 15 is the solution. Solve by dividing. This is a multiplication when things are written side by side. So to undo multiplication, we will use division. And all we're going to do is divide by the coefficient of the variable that we're trying to get rid of. So if that's a negative 6, I have to divide by negative 6, because what I want is to have a positive 1 coefficient out in front of x. When we divide here, even though we're dividing, this is called the multiplication property of equality. I can actually multiply by negative 1/6 instead of divide. So negative over negative is positive 1x. And 48 over negative 6 is negative 8. 1 times x is just x. X equals negative 8. And what we need to do to make sure that we got it right is to take this x out and substitute negative 8 in its place. Negative 6, make sure you put parentheses here, especially when you're multiplying. Put the negative 8 inside. Equals 48. Negative times negative, that's 2 negatives, which is even amount, which gives you a positive. 6 times 8 is 48. Checks out. We're going to do the same thing with solving using multiplication. This is a division problem, so x divided by 4. So we're going to undo that, and I'm actually going to have to write that out to the side here. We're going to undo that by multiplying by 4 times by 4 on both sides. So I get 4x over 4, 4x over 4 equals 20. And 4x of 4 is just 1x, and 1 times x is just x. And to make sure that I did it right, I'm going to take this 20 and put it back in place of x. So 20 over 4 is equal to 5. So 20 divided by 4 equals 5. 5 equals 5, and it does check out. Next example here is going to be solved by multiplying by reciprocal. Okay, so I'm going to have to rewrite this over here again. Give myself some room. Now, since our coefficient here of x is a fraction, we don't divide by fractions, we actually multiply by reciprocals. So what we're going to do is put this in parentheses, and the reciprocal of negative 2 over 7 is negative 7 over 2. Remember, when I multiply, reciprocals are supposed to give me a positive 1, so negative times negative gives you a positive 1. So you can't change the sign, it's just flip the thing over. Over here I'm going to do the same thing, multiply by negative 7 over 2. This ends up giving me negative 14, or positive 14 over 14x. And over here I got a negative 1, or sorry, positive 1 on the bottom, so I'm going to multiply straight across. 4 times negative 7 is negative 28. 2 times 1 is 2. And then I'm just going to reduce. 14 over 14 is 1x. And then negative 28 over 2 is negative 14. 1 times x is just x. X should equal negative 14. To be absolutely certain that's correct, we're going to go ahead and substitute x with negative 14 in the original problem. So negative 2/7 times negative 14 should give us 4. Now I'm going to go ahead and put that over 1. Multiply them together. So negative times negative is going to give us a positive. 2 times 14 is going to give us 28. 7 times 1 is 7. 28 divided by 7 is going to give us 4, equal to 4. So x equals negative 14 does check out. I think we've got one more here. Write and solve an equation. This is a word problem, okay? So in 2004 Olympics, Sean Crawford won the 200-meter dash. So this sounds like important information, so go ahead and underline that. His winning time was 19.79 seconds. That sounds like important information. Here's the question. Find his average speed. So what they're asking me to find is a speed value to the nearest tenth. And this is also important. Nearest tenth of a meter per second. Okay, so they're asking us to find speed given a distance and a time. Okay, so what we have to do is write out an equation. So distance traveled should equal rate times time. That's D equals RT. That's a familiar equation, so there shouldn't be much of a concern here. So distance we're going to substitute with 200. The rate is what we're actually looking for, and the time is 19.79. So R times 19.79. And I'm going to go ahead and rewrite that the other way around, because in algebra we like to have our variables behind and our coefficients up front. So 200 is going to equal 19.79 R, and that's representing our commutative property of multiplication. In order to solve this multiplication, we're going to use the inverse property of division. So we're just going to divide both sides by 19.79. And this should tell us the meters per second. 1979 over 1979 is 1. 1 times R is R. And then we're going to use a calculator to take 200 and divide it by 19.79. You'll notice we have decimal values going in, so it's okay to have decimal values coming out. And that gives us 10.106. It says to the nearest tenth, so I want to round to 1 decimal place. What that means that I got to do is look at the second decimal place, which is the hundredths, And you can see that that does not round that up, so we're just going to write that as 10.1, and this is meters over seconds. So meters per second, and that's his speed, 10.1 meters per second. There are a couple other problems in the textbook, so if you want to go ahead and take a look at some of the word problems or a couple of the other one-step equations, go ahead and do so. Just keep in mind that the rules we did here for equations also apply to inequalities, the exact same rules.